Hello, this is Quadratic Solutions, Quadratic Exercises, Linear Solutions, and Linear Exercises. I have the organization on page 1. Uh, the name of the program is KOPE, capital K-O, capital P, capital E. On the organizations, we have the X values are less than or equal to 9, and greater than or equal to minus 9. These are more or less exercises in algebra, arithmetic, calculator, roots, simple and complex linear equations, notation like I sub A, I sub B, I sub C, and I sub A and I sub B. There are 6,498 parabola solutions, 233,928 parabola exercises. There are 361 linear solutions, 12,996 linear exercises. These are the formats from 1 through format 4. Format 1 on the right implies KOPE, that's the name of the program, KOPE, Parabola Solutions, and follow the examples, parabola problems. To the left, it's 9 steps. Format number 2 implies KOPE, Parabola Exercises. To the left, it's 1 problem, 2 adjacent exercises, and the X values. In the parabola exercises, you're given f of 0 and m of 0. We're going to use the two X values at 0 and 1. And we're going to calculate the f of 1. And the B part, we're going to be given f of 1 and m of 1 and calculate f of 0. Format number 3. On the right, it implies KOPE, linear solution. The A part is graph the line, and B part is graph m sub x, which equals m, which equals delta y over delta x, which equals I sub a. And the left side implies use 2 adjacent x values. Format number 4, KOPE, linear exercises. On the right implies linear exercises. On the left, it use 2 adjacent x values. Examples, x values are 0, and on the right we have two exercises. A given f of 0 and m of 0, calculate I f sub 1. And B part given f of 1 and m of 1, calculate f of 0. Now we have examples of these 4 formats. Format number 1, parabola solutions. KOPE, parabola solutions. That's on the right. On the left, it's 9 steps. We go through 9 different steps. The first step is y equals f of x, which equals 1x squared plus 2x plus 3. Oh, that's the given there. The I sub A, I sub B, I sub C equals 1, 2, and 3. It's a notation that implies that y is equal f of x, which equals 1x squared plus 2x plus 3. Number 2 is y prime. That's the tangent line, the slopes, the change in y. Y prime equals to f prime of x, both meaning change. which is equal to 2x plus 2. The change in 3, for example, is the line y equals 3. There's no change in y. Number 3 is another name for y prime, which is m of x, 2x plus 2. 4 is the axis, the line that cuts the parabola in two equal parts. The A part is define the axis by using a formula, UF. And the formula is x equals minus b over 2a, which is x equal to minus 1. The B part is do not use formula. That's where the change in y is 0. M sub x is 0, which is 2x plus 2. And x turns out to be equal to minus 1. We have a linear equation there. Step 5, we have roots. The roots could be one real, where the parabola is tangent to the x-axis, two real, where it cuts the x-axis in two places, and two imaginary, where it misses the x-axis entirely. And we use the section of the formula, b minus square root of b squared minus 4ac. If that number under there is a 0, it's one real root. If it's a positive number, two real roots. And if it's a negative number, it's an I term, it would be two imaginary roots. So the numbers are 4 minus 4 times 1 times 3, 4 minus 12, and that turns out to be 2i root 2, and that implies two imaginary roots. 6, the minimum point. It turns out that when your numbers are 1, 2, and 3, the first number, I sub a, is a positive number, so that implies minimum. If it were a negative number, it would imply a maximum of the parabola. So look for the minimum. That's where we use it where the tangent is 0 to the parabola, and that's where x equals minus 1, and we find the ordered pair where x equals minus 1 comma 2 is the minimum of f of x. Step 7 is the roots. The roots, we use a formula, UF minus b, x equals minus b plus or minus root of square root b squared minus 4ac all over 2a. And plugging in the numbers, we already solved for b squared minus 4ac. So we end up with x equals minus 1. Do not use formula. That's where the f of x is 0, or supposedly crosses the x-axis, which is an I term. It doesn't cross the x-axis. So that gives you a complex quadratic equation, which is x squared plus 2x plus 3 equals 0. And solving that equation, we come up with x equals minus 1 plus or minus I rad 2. And that we circle because it corresponds with we got by using the formula. Number 8, we have 9 steps. This is the 8 steps. Given the roots, solve for where the function is equal to 0. And whenever we have the product of x minus r1, x minus r2 equals 0. Whenever we substitute for r1 and r2, we come up with the parabola function of the parabola. We write the equation, and then we change the x minus to an x plus, which gives us another equation. And then we multiply it out. Now, in multiplying it out, we can either multiply it out on scrap paper, but it turns out to be that x times x is x squared, and our first and outer and inner term turn out to be an x term, so it's x plus x, and the last value is the product of the I rad 2 and plus I rad 2, minus I rad 2 plus I, and a minus I times a plus I is 1, rad 2 times rad 2 is 2, so it turns out to be 1 plus 2 is the numerator. And we come up with x squared plus 2x plus 3 equals 0, and that matches. So we circle that, and we circle the solve for up here. 9 is graph the parabola. and implies points greater than or equal to 5. Now, a computer could use as many points as they want to, but we only use 5 points. Write a simple quadratic equation, so we set f of x equal to 3. That gives us a simple quadratic as x squared plus 2x plus 3 equals 3, which gives us x squared plus 2x equals 0. We solve that by factoring. It turns out x equals 0 and x equals minus 2. And that gives us two ordered pairs of that parabola. Find, although we have three ordered pairs altogether, the minimum and the 0, 3 and the minus 2, 3. And we have to find a fourth, two other ordered pairs. So we let y equals 4. We solve that function equals 4. And it turns out to be x equals minus 1 plus or minus root of 2, which gives us 2x values plus 0.41 and minus 2.41. And we plot that and we label the points on the parabola. And that concludes step 9, the last step.